Section 2.6, combinations of functions and composite functions. Now, the first thing we will discuss on this section is something that I mentioned in section 2.5, which is the domain of functions given the equations. Now, we went through all the different types of common or parent functions that there are, all the families of functions. And out of those functions, we discovered that there was only one of them out of the bunch whose domain is not negative infinity to positive infinity, and that was the square root function. Now, what makes a square root not to have a domain of negative infinity to positive infinity? The fact that I cannot have a negative number inside of the square root, because a negative inside of the square root, it makes the square root non-real or imaginary. So there are two types of functions that will make that happen. In other words, that will make the domain to be have excluded values. So that's the first thing we're going to be looking at here, finding a function domain. And when we're talking about equations, this is what we are going to learn here. So it gives you the definition of domain as usual, but now this is basically the main thing. We need to exclude from a function's domain any number that either causes the denominator of a function to become a zero, or any number that causes the function to have a square root of a negative number. So basically it's telling you only if I have a function that has x on the denominator, and only if I have a function that has x inside of the square root. Basically, these are the only two types of functions for which the function is not defined for all values. Because, for example, what happens if I have a 0 right here on the denominator of this fraction? Then it's going to look like this. If I have a 0 on the denominator, then 1 divided by 0, that one is not an actual value, so that we say is undefined. Okay? Anytime we have division by 0, the value of the function is non-existent. So that is the reason, once again, that whenever we have x on the denominator of a function, we need to exclude anything that causes that denominator to be equal to 0, because anything that makes it a 0 is not defined in the function. Now, the same thing happens with the square root. But on the square root, we have to exclude anything that makes it negative. For example, what if we have a negative 1 inside of the square root? The square root of negative 1, that is non-real. We talked about the non-real solutions before. The square root, what if x is negative 2? The square root of negative 2, that is non-real, and so on and so on and so on. So for the square root, we need to exclude anything that makes the square root a negative number, because that will be a non-real solution. And for the x, whenever we have x on the denominator, that we need to exclude anything that causes the denominator to be equal to 0. Other than that, if you remember, we focused on these functions, f of x equals x. The domain was from negative infinity to positive infinity. X can be any number. Now, if we talked about f of x equals to x squared, same thing. We said that the domain was from negative infinity to positive infinity. X is any number. And so forth for the rest of the functions. Now, let's go ahead and find the domain of the following functions. F of x equals to x squared minus 6x plus 15. On this first function that we're given here, you see that, okay, this function doesn't have x inside of a square root, and it doesn't have x on the denominator. So, since this one does not have x on the denominator or a square root of x, what does that automatically mean? That the domain is any number from negative infinity to positive infinity. Now we can take a look at it in this way. The highest power of this function is x squared. So that tells me that this function is going to look like a parabola, and the domain of a parabola is from negative infinity to positive infinity. Now let's go ahead and discuss the next one here. Find the domain of this function. F of x equals 48 over x squared plus 21x plus 90. Now, on this specific function, we need to exclude anything that causes the denominator to be 0, because we have x on the denominator. And anything that makes it 0 on the denominator is going to make this fraction what we call undefined or not defined. So in order for me to find the values that make that denominator 0, so we need to first of all equal the denominator to 0 and solve for x. Now, this is a quadratic equation. In order for me to solve a quadratic equation, the process that we're going to use is what we used back then in section P.5, which is factoring. So the first step in factoring is finding the greatest common factor. Now, this function right here, this denominator, x squared, which is 1, 21, and 90, the greatest common factor of them is 1. Then this is a trinomial, so we're going to factor using the a times c method, which is 1 times 90, right? So we need to get two numbers that when multiplied they give me 90, and right here this means that when those numbers are added they give me 21. So 1 and 90 doesn't work. 2 and 45 when added they don't give me 21. 3 and 30 when added they don't give me 21. 5 and 18 when added they don't give me 21. 6 times 15 is 90, and 6 plus 15 gives me 21. So these are the correct factors for this trinomial. So we're going to have x and x on each one of them, and then we're going to have the factors, which is 6 and 15. And they need to add to positive 21, so in this case both of them need to be positive. Then the last thing of this factoring process is that, remember, there's a 1 in the front, so we have to divide by 1. However, if I divide by 1, the factors are going to stay the same. So anytime the coefficient in front of the x squared is a 1, you don't have to divide when you're factoring out. Okay, that 1 is not going to make any change. So then what we're going to do is we're going to set each one of these factors equals to 0 separately, and we're going to solve for x because we want to find out what makes them 0. Right here, x is equal to negative 6, and right here, x is equal to negative 15. So what does this mean? So that means that x can be any number with the exception of negative 6 and negative 15, because negative 6 or negative 15, if I substitute them into the x of this function, it's going to make this fraction not defined or undefined, meaning that it's going to make the denominator equal to 0. So let's go ahead and write the domain in interval notation. So the domain in interval notation would be, if we want to say that the domain is anything with the exception of negative 15 and negative 6, we're going to say that the domain goes from negative infinity and then it stops at negative 15, or then it continues after negative 15 and then it stops at negative 6, or then it continues after negative 6 and it keeps on going to positive infinity. This is my domain in interval notation. What if I wanted to write the domain in set notation? Then you will write it like this: the set of all x such that, and remember there's a couple of symbols that we can use for the set notation that I mentioned back in section 2.1, which is whenever we use this set notation to give the domain, we use less than, greater than, less than or equal, greater than or equal, and not equal to. So the one that will basically best closely match what we want to do is the not equal to, because we want to say that the domain is any number x with the exception of negative 6 and negative 15, so we can say but not equal to negative 6 and negative 15. So that is my domain in set notation. The following question, now we're going to find the domain of this function. This is a square root function. Now, to find the domain of a square root function, we have to exclude, remember, anything that causes the square root or the number inside of the square root to be negative. In order for me to exclude anything that makes it negative, all I have to say is this: 50 minus 5x must be greater than or equal to 0. That's the same thing as saying that we're that we don't want it to be negative. We just want it to be either a positive number or 0. Okay, so we're going to find all the values of x for which this expression inside of the square root is not negative, meaning greater than 0 or equal to 0. So let's go ahead and solve for x. So we need to move the 50 over to the other side to leave the x by itself. So we're going to get negative 5x is greater than or equal to negative 50. Then we have to divide both sides by negative 5, and that's going to give us one little thing that you need to keep in mind is this. This is called the multiplication property of inequalities, which says the following, that when I divide or multiply an inequality, both sides of an inequality by a negative number, the inequality symbol is going to change the direction. So then this is going to end up in x is less than or equal to positive 10. So that means that if x is a number less than or equal to 10, then this number inside is going to be a positive number. Okay. So to write the domain, we're going to write it in two different ways. So in interval notation, if I want to say that the domain is anything except anything that as long as it's less than or equal to 10, then we're going to say that the domain starts from negative infinity, comma, and it stops at 10, including 10. Or if we want to write it in the set notation, we can say that the domain is the set of all x such that, and remember for the set, this is a symbol that we are allowed to use for the set notation. So we can write it like that. X is any number as long as it is less than or equal to 10. That's basically how we say that. And that's the domain for this function. Next one. Now the next thing we're going to work on is combinations of functions. This is going to be the definitions we're going to do next. Now it states here, let f and g be two functions. The sum, the difference, the product, and the quotient of those functions, which is the addition, subtraction, multiplication, and division of those functions, are functions whose domains are the set of all real numbers common to the domains of f and g. Okay, so basically, whatever the domain of f and g is, the domain of the addition, subtraction, multiplication, or division of those will be the same as basically the common values from the domains of f and g. So the domain of f and the domain of g combined, that will be the domain of the sum, the difference, the product, and the quotient. Now for the quotient, there's one little thing. Given that for the quotient it has a little difference, because remember that when we have a division, the only thing is that we need to exclude anything that causes the denominator to be equal to 0. Okay? With the exception of the quotient, all the other three will be exactly the domains of f and g combined. Now let's go ahead and talk about this problem right here. Find f plus g, f minus g, f g, and f over g, and determine the domain of each one of those functions. So let's go ahead and start with f plus g. So we're going to first create the function f plus g of x. So what does that mean? That we need to add the function f of x plus the function g of x. So we're going to add the function 3x squared plus 19x minus 14 plus the function g of x, which is x plus 7. Now all we gotta do here, of course, is combine like terms in this function. That's what we can do. So we can combine the x's. So the 3x squared is gonna stay by itself, but we can combine the 19x plus x, which is gonna give me a plus 20x. And then we can combine the negative 14 plus 7, which is gonna give me a negative 7. So this is going to be the function f plus g of x. 3x squared plus 20x minus 7. Now, just by looking at the functions, we need to find the domain of this one. Looking at f of x, since f of x has an x squared, and also we don't have a x on the denominator, or we don't have x under the square root, that automatically means that the domain of f of x goes from negative infinity to positive infinity. Likewise, the domain of g, since the g doesn't have x on the denominator or x under a square root, that means that the domain is negative infinity to positive infinity. Also, if you look at the shapes of these two functions, g of x is a line, f of x is a parabola. So both of them have domains of negative infinity to positive infinity. So, what does it mean? The domain of the sum of those two functions will still be negative infinity to positive infinity. So whatever the domains of f and g are combined, that will be the domain of your addition of the two functions, subtraction or multiplication of the two functions. Now, let's go ahead and look at the next function. Now we're going to find f minus g. So for this one, what we need to do, we need to subtract the functions f of x minus the function g of x. Now when we subtract g of x, we need to subtract everything that is in g of x. So we have to put it in parentheses. So this is 3x squared plus 19x minus 14, that's f of x, minus g of x, which is x plus 7. So we are going to first of all distribute the minus sign right here, so we can subtract everything that is in g of x. So we're going to get f minus g of x equals to 3x squared plus 19x minus 14, then minus x minus 7. Then what are we going to do? We're going to combine like terms. So the 3x squared is going to stay alone. Then 19x minus x is plus 18x. Negative 14 plus negative 7 is negative 21. So the function f minus g is going to be equal to 3x squared plus 18x minus 21. And according to what we said before, since the domain of f and g are both negative infinity to infinity, the domain of f minus g is also negative infinity to positive infinity. And that concludes f minus g. Now the next function is going to be fg. So we're going to do the product. So we're going to find the function fg of x, meaning that we're going to multiply the functions f of x times g of x. So we're going to multiply 3x squared plus 19x minus 14, we're going to multiply times x plus 7. Times x plus 7. Okay, so let's go ahead and multiply these two functions. We have 3x squared times x is 3x to the third power. 3x squared times 7, it's going to be positive 21x squared. Then 19x times x is going to be plus 19x. Then 19x times 7, so it would be 70 and 63, which is going to be 133. Okay, so then we're going to have plus 133x. And then the last one is going to be, oh, the 19x times x is going to be 19x squared. I forgot the square there. And then the last one, we're going to multiply. Negative 14 times x is going to be minus 14x. And negative 14 times 7, so we multiply negative 14 times 7 is negative 98. Then we're going to combine like terms again for this function. So for the function f times g of x, we're going to get 3x cubed is going to stay alone. We can combine the x squares. 21x squared plus 19x squared is going to be plus 40x squared. 133x minus 14x is plus 119x, and then minus 98. and this is the function f times g of x. 3x to the third power plus 40x squared plus 119x minus 98. So what is the last thing we're going to do is find the domain. Since the domain of f is negative to positive infinity and the domain of g is also the same, so the domain of f times g will also be negative infinity to positive infinity. And last but not least, now we're going to find f over g of x. On this one we are going to divide the two functions f of x divided by g of x. So it's going to be 3x squared plus 19x minus 14 divided by g of x, which is x plus 7. Now, one thing that we know for sure from this function is that this function is not defined in the domain of negative infinity to positive infinity. What is the reason for that? Is because this one has x on the denominator. So we need to exclude anything that causes that denominator to be equal to 0, and that the value that makes that denominator equal to 0 would be x equals to negative 7. So when I write the domain for this function, we're going to say that the domain is any number with the exception of negative 7. So if you write it in the set notation, you would say the set of all x such that x is anything except for negative 7. Now, if we want to write it in interval notation, we would say that the domain starts from negative infinity, it stops at negative 7, or it continues after negative 7, and then it keeps going down to infinity. And that is my domain either in set notation or in interval notation. Now, let's go ahead and continue with this function. Whenever you get a function in the form of a fraction, right here what we have to do to simplify it, this is how we simplify a function that is a fraction. We have to factor and divide any common factors, if any, of course. Now, this numerator, that one is a trinomial, so we might be able to factor by doing the AC method. So that's what we're going to do. 3 times 14, it's going to be 42. So we need to find two numbers that when multiplied they give me 42, and when subtracted they give me a 19. And that would be 21 times 2. 21 minus 2 is equal to 19, and 21 times 2 equals to 42. So this function can be factored. So that's what we're going to do. So the factors would be, of course, x and x on each one of them right here, and the two factors, which is positive 21 and then minus 2. But remember, this is not it, because we have a 3 in front of the x squared. What does it mean? That we have to divide both of them by 3. So if I divide the first one by 3, I'm going to write it on the side right here. So the first one is going to give me x plus 7, but the second one we cannot divide by 3, so we're going to move the 3 in front of the x. So it's going to give us a 3x minus 2. Everything over x plus 7. Now the question is, can we simplify? How do we know if we can simplify? After we factor, if you see that there's a common factor that can be divided out, you have to divide it out. So we see x plus 7 is the same as x plus 7. Those are called common factors. So we can divide the x plus 7, and my final function f over g of x, it is going to be 3x minus 2. And that concludes this question. So we already found f plus g, f minus g, f times g, and f over g. Okay, so now we're going to get into another concept. These are the combinations of functions. So for any given functions, that's how we do combinations. Now we're going to talk about composition of functions. This is the last operation of the section. He tells me that the compositions of the function f with g is denoted by f, like open circle g, you read it as f of g. Okay? Is defined by the equation f of g of x equals f of g of x. So what does this remind you of? basically this is something we did on the section 2.1 in evaluating functions, which means that f of g means that you're going to substitute or replace the function g inside of the function f. Okay, so that's basically what it shows us right here. The function g is going to be substituted into the function f. And where do we substitute it? Into every x of your function f. Just the way we do evaluating functions. When we evaluate a function, we replace the x with the given value. Same thing is going to happen here. If I want to evaluate this function with the function g, I need to replace every x in the function f with whatever the function g is. Then, to find the domain of the composite function, we need to exclude anything that is not in the domain of g and exclude anything that is not in the domain of f of g. Those are going to be the two domains that we're going to look at for the composite function. That's what we need to look. Alright, so now we're going to get into this question for f of x equals 2x minus 5 and g of x equals to x squared minus 2. We're going to find the following functions: f of g of x, g of f of x, f of g of 0, and g of f of 0. So right here I'm going to show you how we can find the function values for any given x in two different ways. So the first thing that we're going to create is that we're going to create the function f of g of x. So that is the first one we're going to do. So let's go ahead and begin. So f of g of x. So let's take a look. Okay, moving on. So f of g, what does that mean according to the definition when we see f of g? So let's take a look to this. So letter A, f of g of x. That means that you need to substitute g of x into f of x. That's what f of g means. So which means that I need to replace the function g of x, which is x squared minus 2, into every x of your function f of x. Now f of x only contains one x, so you're just going to put it into that x. So my new function is going to look like this: 2 times x minus 5. But like we said, the x was going to be replaced with the function g of x, which is x squared minus 2. And then we have to simplify it. So this is what the function f of g is going to mean. So we're going to simplify this. So remember that this f of g is the same as this, right? F of g of x. So we're going to simplify by distributing first. We're going to distribute this. So that gives us a 2x squared minus 4, and then minus 5. The last thing that we can do to simplify this is that we can combine like terms. So the like terms will be minus 4 minus 5, which is going to be a minus 9. So 2x squared minus 9 will be the answer for this function, f of g of x. Second, now we're going to do the other function. Now on letter B, we need to find the function g of f of x. What does it mean by this? That means that now we want to find a function, the function f of g of f, which is going to be found by replacing the function f into the function g. So the function f, which is 2x minus 5, is going to be replaced and substituted into every x of your function g. So my function g of f is going to look like this: x squared minus 2. But instead of x, we're going to replace the x with the function f, which is 2x minus 5. Now, we talked about this before. The 2x minus 5 squared means that you can do the square of the first term, which is the binomial square, the square of the 2x, and plus 2 times the first times the second terms, plus the square of the second term. Or simply, that means that you can do this: multiply 2x minus 5 times 2x minus 5. That's what the 2x minus 5 square is going to mean. So let's do the multiplication, and I'm going to write it the other way. So remember that the g of f basically means this. Substituting the f inside of the g, right? So that's what we did. So now let's go ahead and distribute this. So we're going to get 2x times 2x. That's going to give us 4x squared. Isn't that the same thing as squaring the 2x? That is the same thing, right? Then we're going to multiply. 2x times negative 5, that's negative 10x. Then we're going to multiply. Negative 5 times 2x is negative 10x. And then we're going to multiply. Negative 5 times negative 5 is positive 25. Then we can combine like terms. So if we combine like terms here, we're going to get 4x squared. Negative 10x minus 10x is minus 20x. And then plus a 25. And this is the function g of f. I think I wrote it too many times. G of f of x. Okay, that is the function g of f. Alright, so the next thing that we're going to do is we are going to find letters C and D. Now, there are two ways that we can do this for C and D. One of the two ways is this. F of g means that you need to substitute g into f. Now, probably this is going to be the longest way of evaluating if we're not given these functions. Now, f of g means that we need to substitute g into f. So that's exactly what we did right in this letter A. Okay? But that's not what we want ultimately. After we substitute g into f, that gives us this. But now we want to find the value when x is equal to 0. So meaning that you need to replace the x with a 0 right in this function. That is one way. So since I already know what f of g is, all I am going to do to find letter C, I'm going to find f of g of 0. That's what that means. So we already know the function f of g, which is this one. So all I'm going to do to find the value is replace the x with the 0. That's what we want to do. And that is going to give us 0 squared, which is 0, times 2 is still 0, minus 9 gives us a negative 9. So f of g of 0 is negative 9. That's the value. So likewise, if we want to do letter D is asking you to do g of f of 0, which means this. But we already know what g of f is, so we already found it up here. So to find g of f of 0, we can replace every x in this function with a 0. And if I replace every x with a 0 right here, that's going to give us 0 squared, which is 0, times 4 is still 0. Negative 20 times 0 is minus 20, plus 25, that gives us a 25 as an answer. So that means that g of f of 0 is equal to 25. So this is one of the ways that we can do that when we're trying to evaluate a composite function given a number. I'm going to show you now, what if I wouldn't know what these two functions are, the a and the b? How can I find a function value without having to find those functions? That's what I'm going to show you next. So for letters C and D, you also have this choice. So these are my functions f and g, correct? So, and the questions for letter C says, I'm still going to do this one in a different way. It says find f of g of 0. So what you are going to do to find this value, f of g of 0 means this. F of g of 0, which is this. The first thing you would do is you need to find the value of g of 0, meaning that I need to find the value of y when x is equal to 0 using the function g. So this is the first thing that we're going to do. So I'm going to find g of 0. So I replace the x with the 0, and that is going to give us g of 0 equals 0 minus 2, which is negative 2. So g of 0 is negative 2. So this value inside is equal to negative 2. So then to finish this problem, what do I need to do? Now I need to find f of negative 2. What does it mean by f of negative 2? Find the value of y when x is negative 2 using the function f, which is 2x, which is negative 2, minus 5. Now we're using this one, you see? And if I do that, then this is going to give us f of negative 2 equals negative 4 minus 5, which is going to give us a negative 9. And we'll still get the same value. We can do the exact same thing to find g of f. But first we need to substitute the function f with the 0, and whatever that answer gives us, we need to substitute it into the function g, and that should give us also a 25. Now, we're going to work on the next function, in which now we're going to find the composition of these two functions, but also we're going to find the domain. So we're going to find it's a two-part question. So the first thing that we are going to do is we're going to find letter A. We need to find the composition of these two functions. So, what does it mean by the composition? I need to substitute, to find f of g. That letter A, which is f of g, means f of g, meaning that we need to substitute the function g, which is 3 over x, into every x of your function f. So you need to replace it into this x down here. So that function f of g, therefore, is going to look like this. 5 over x, but the x is going to be replaced with 3 over x, and then we have a plus 8. So, what do you see on this function? On this function, it is very important that we determine what the domain of g is, because you see that if I just leave it like this, on this function, it has a fraction right here. And what do we know about a fraction? That the denominator cannot equal to 0. So that's why it tells you right here on the definition, you need to exclude anything that is not in the domain of g. So you need to exclude anything that is not in the domain of g. So right here, the g is going to be the function that we're substituting into the function f. So the one that we're substituting, we need to make sure we exclude any value that is not in the domain of this function. So, what value, I'm just going to do that as we go, what value must be excluded because it makes this fraction undefined? Well, in order for us to find it, we need to set the denominator equals to 0. That's what we do to find the excluded values in a fraction, because remember that the denominator cannot equal to 0. So if I set the denominator equals to 0, then x is equal to 0, right? Because it is just x. So x equals 0, that's the number that will make this fraction undefined. Okay, so let's keep that in mind. But now the question is, I still need to simplify this fraction. Now, this is called a complex fraction. In order for me to simplify a complex fraction, what we need to do is we need to multiply the least common denominator into every term of this fraction. So I need to multiply this term, I need to multiply this term, and I need to multiply this term, all of them by the least common denominator. Now right here, my least common denominator would be x, because you see this one is over 1, and the 5 is also over 1. So the denominators are 1 and x, so the least common denominator is 1x. So we're going to put that here, 1x, which is just x. So what I need to do to simplify it, I need to multiply this, the numerator of this fraction by x, this fraction by x, and also this fraction by x. That's how we simplify what we call a complex fraction. And this is going to give us 5 times x is going to be 5x. Now, if you look at the denominator, right here, the x and the x right here, they're going to simplify each other. They're like factors. And that's going to leave you with 3 plus 8 times x, which is 8x. And this is a fraction in simplest form. F of g of x is equal to 5x over 3 plus 8x. Now, before you can ensure that this is your final answer, you need to check if this fraction can be simplified. To check if it can be simplified, all you need to do is you need to see if there's any factor, any number that can be factored from the denominator, anything that can be factored from the numerator, and seeing if you can divide those factors. Or simply just look at all the three terms that we have here and see if they can all be divided by any number. 5, 3, and 8, they cannot be divided by anything, so that means this fraction is already in simplest form, in lowest terms, simplified. Okay. But wait a minute, we ended up with another fraction in which we need to exclude anything that causes the denominator to be 0. Remember, that's what we do for the domain whenever we have a fraction. So in order for us to find out the value that makes the denominator 0, we need to equal that denominator to 0 and solve for x. So we subtract 3 from both sides, so that gives me 8x equals to negative 3, and then we divide it by 8, so we get x is equal to negative 3/8. So x is equal to 0 and x is equal to negative 3/8, those are the only numbers that must be excluded because they're going to make my fraction undefined. Okay, so we need to exclude 0 and negative 3/8 from the domain. So let's go ahead and write the domain on this fraction right here, on this function. So we can say that the domain, now if we put it in set notation, we say that the domain is the set of all x as long as x is not equal to negative 3/8 and 0. Now if we want to write the domain in interval notation, we're going to say that the domain is anything from negative infinity, comma, and it stops at negative 3/8, or it continues after negative 3/8 and then it stops at 0, or and then it continues after 0 and then it goes to positive infinity. So that's the domain either in set notation or in interval notation. And that's what the two parts of the questions are. Find the function f of g, and B, find the domain of f of g, which we already did. Let's go ahead and answer one more question on finding the composite function, but we're going to use different types of functions this time. So we're going to use this one. So for f of x equals x squared plus 7 and g of x equals the square root of 1 minus x, we're going to find the function f of g of x and the domain of the function f of g. So to find the function f of g of x, we talked about it. What does it mean by f of g of x? It means that we need to substitute the function g of x into every x of the function f of x. That's what that means. I'm going to put it right here. So f of g of x. I'm going to write it differently. Remember that that symbol means this. F of g of x. So that means that I'm going to substitute the function g, which is the square root of 1 minus x, into every x of the function f. So it's going to be replaced into this x, right? So instead of saying x squared plus 7, that x is going to be replaced with the square root of 1 minus x, which is my function g. And this is something I kind of mentioned in section 2.1, and I'm going to mention it back again. The square root and the square, they're opposite operations. They simplify each other. So the square root and the square, they're going to simplify. So we're going to have the following function. So then if they simplify each other, then we're going to end up with the function f of g of x equals, then it is just going to be 1 minus x and then plus 7. And on this function we can combine like terms. We can combine the 1 and the plus 7, that's going to be plus 8. So we can write it as 8 minus x or negative x plus 8. And this is the composite function f of g. Now we need to determine the domain. So before I simplify these, this was my function f of g before I simplified it, right? And what do we originally have on that f of g function? We have a square root. Remember that for the square roots, we need to exclude anything that causes the square root to be negative. So we're going to go to that square root that we have right here, and we need to exclude anything that causes it to be negative. How do we do that? By setting it greater than or equal to 0, and then solve for x. So we're going to subtract 1 from both sides, so we're going to get negative x must be greater than or equal to negative 1. And then to solve for x, we need to divide both sides by negative 1. But when we divide by a negative on both sides of an inequality, the inequality symbol switches direction. So this is going to become a less than or equal. So it's going to be x is now less than or equal to positive 1. So x has to be any number less than or equal to positive 1. Now, after we simplified it, we ended up with this function. Do we have any square root on this function, or do we have any denominator of x on this function? No, right? So that means that this function has a domain of negative infinity to positive infinity, right? So that one, we don't count it, okay? So, if we put those two domains together, then the domain of my composite function f of g is going to be, so this one doesn't count, so because we already know that that one doesn't have any excluded values. The only things that we need to exclude is anything that will make that square root a negative. So, and that means that x must be a number less than or equal to 1 in order for that square root not to be a negative. So we can write it in set notation like this: the set of all x such that x is any number less than or equal to 1. Or if we write it in interval notation, we would say that the domain is anything from negative infinity all the way to positive 1, including positive 1, because it's less than or equal to 1 means from negative infinity to 1. So that would be the domain in either set notation or interval notation. That's the answer for letter B. And the function f of g, that's right here, that's the answer for letter A. So we're going to have two more questions to answer here. So express the given function f and g as a composition of two functions f and g, so that h of x equals f of g of x. So once again, express the given function h as a composition of two functions f and g, so that f of h of x equals f of g of x. So basically, this function represents the composition f of g. That's what this is telling you. Basically, it means that f of x, this h of x is the same as this. It means that g of x was already substituted into f of x, and it generated this function. Okay, so there's many ways that we can actually separate this function. Okay, we need to think of two functions, f and g. This is what the question is going to be, f of x and g of x, so that when I put the g of x into the f of x and I simplify it, it's going to give me this function back. Now, the simplest possible case, it is always going to be this: the whole inside of this function right here, because what we are replacing, we're substituting the g into f. So that means that the whole inside of the function f of g is going to be g, because that g of x is the one that we're replacing in. So that's the easiest possible case of thinking about it. So x to the 5th minus 9 would be g. And now let me ask you this: before we substituted the x to the 5th minus 9 inside of this function, what was originally inside of this function? It was an x. So it was basically a 6th root of x, because whenever you replace it into the x. So originally, if I put the x to the 5th minus 9 into the x, it becomes x to the 6th root of x to the 5th minus 9. This is one way of thinking about it. Now, what if I also say this? I can also come up with many other functions, but the most common one is going to be this one. I can also say that two functions that will generate that function, it could be that what if the g of x is going to be my x to the fifth. So what does it mean? F of x is going to be the sixth root of. Before I substituted that x to the fifth right here, what was that x to the fifth originally? It was an x, so x minus 9. If I substitute the x to the fifth into the x, it becomes x to the fifth minus 9 inside of the sixth root. So, but like I said, the most common situation that you're going to encounter is this. When everything inside, it's going to be the function that you substituted, which is my function g in this case. Now, let's think about this one for a minute, and let's use the most obvious case. Just know that there's many different ways in which we can actually obtain that. That is for sure. But we're going to use the most obvious case based on what I mentioned to you on the previous question. So this function right here represents the function f of g of x. That's what that function is. Meaning that g was put into f to create this. So I need to separate them. That's what I need to do. So my g of x is going to become the function that was substituted, and what was substituted here, we can say the whole inside of this function, which is 8x minus 1. That is the most obvious case. Everything inside is going to be my function that was substituted, which was g of x. And before I put that 8x minus 1 on this denominator, what was that denominator originally? It was an x. So my f of x will be 1 over that denominator x. And like I said, this is the most obvious case. Can it be written in many other different ways? Yes, it can. But mostly this is the case that you will more than likely see in these situations. And this concludes section 2.6, which is combinations of functions and composite functions.